Good morning. So me, my partner Viridiana, and my partner Camila are going to talk about hypergeometric distribution. So Viri, what is hypergeometric distribution?
The hypergeometric distribution is a concept in statistics that we use when we want to count things in a group of objects without putting them back after choosing them. An example could be if you have a box with red and blue balls, and you want to select a certain number of red balls without replacing them. The hypergeometric distribution helps you calculate the probabilities of how many red balls you could get in that selection without replacing them. In short, the hypergeometric distribution is used to count things in a population without putting them back after each election, and is useful in situations where that matters.
This probability function with a specific formula that takes into consideration the size of the total population, uppercase letter n. And k is the number of elements of interest, and lowercase n, the formula that helps us to understand how many combinations can be.
The k properties in the hypergeometric distribution, there are some important things that you should know. The first is there is no exist replacement, because the most important property is that we don't pop back what we choose. Once we select something from the population, it is not available for the next selections. The second is that depends on the actual population. The probabilities in the hypergeometric distribution depend on how many items of interest there are in the total population. For example, if you have more or less of those elements, the probabilities change. And the last is the non-independent outcomes. In hypergeometrics, the outcomes of one choice affect the probabilities of subsequent choice because the population changes each time we draw something. These properties are essential to understanding how the hypergeometric distributions works and how it applies in situations where we don't know one or we cannot replace what we choose.
So next we have some real-life examples, such as quality control. In a factory, product samples with a replacement are used to check quality. The hypergeometric distribution helps calculate the probabilities of finding defective products in the sample. Also, a real-life example will be surveys. When surveying a population, if you want to make sure you don't talk to the same person twice, the hypergeometric distribution will help calculate the probabilities of obtaining diverse samples. And this one next, I think, is a very common example when you don't want someone to pick someone twice in a team selection, for example, in sports. So when you choose people for a sports team or a work project, and you don't want the same person to be selected twice, this distribution helps you calculate the probabilities of selecting certain numbers of people with certain skills. In conclusion, the hypergeometric distribution is a powerful tool that helps us calculate probabilities when we select things from a population without putting them back. It is useful in real-life situations, even when we don't think we use it, such as product quality control, team building, and surveys, where we do not want repetition in our selection. Remember that this distribution depends on the size of the total population, the number of elements of interest, and the size of the sample. Understanding how it works and when to apply it is essential to make informed decisions in situations where we don't want to replace what we select. Thank you.